Right. So, as I was saying, so DevOps is not a programming language, or it is a not software, or it is not a platform. Okay, these kind of terminologies you should not use. You should use only DevOps is a culture. Okay, why it is called as culture, we'll see just now. Okay, so if you observe, the basic steps of a software development life cycle. Okay, there would be some developers who will be writing code. Okay, whether they might be using any programming language. Okay, C, C++, Java, or something. Okay, suppose there is a developer who will be writing the code in his laptop, right? So the code will be written in his laptop. So now once he has written the code, okay, this is developer. So once he has written the code, the next step would be, okay, so he will send the code to the build team. What this build team will be doing? Okay, there will be a team called build team. Okay, we'll call them as build and release team. We'll talk about much about this later on a high level. Okay, so he will send the code to build and release team. What this team will do, they'll collect the code from the developer and they will build the source code. Okay, what do you mean by building here? So developer will be writing into some programming language, right? For example, if it is Java, he might be writing code into public static void main, or if it is C language, it hash include stdio.h, right? So the code will be like this, something. Okay. Now this code has to be deployed into server so that end user can access the code, right? Suppose if he's developing some Facebook kind of application, he will be writing code in Java. Okay, and the Facebook application needs to be deployed into server environment, okay, into a server, so that we people can connect to the server by using facebook.com, and then we can use the application, right? So the application has to be deployed into server environment so that people like us can go ahead and use the application. We'll connect to the server by using facebook.com, and we can go ahead and no use the application. Okay. So what we are using? We are using the application, right? Application which we need to be deployed into server environment. This is application, right? This is application. Developer, what he has written? He has written code for the application, right? If we directly deploy this code into server, what happens? If we people are using the internet, right? Whoever wants to use the application, what they'll get the code, not the application. For an example, to as easy understanding, let me check. Okay, if you want to use Facebook application, we'll be using facebook.com, right? This is an example. What we are getting application, not code, right? Okay, if we deploy the code into server environment, definitely we will get the code like this. This is developer's written code. Okay, we'll be getting code like this. But end user wants code or application. End user wants application like this. Now, how can we convert the code which is written by the developer into an application? Okay, are you getting my point? How can we convert the source code which is written by the developer into an application? This is phase number one and step one for any DevOps engineer. Okay, we should be able to convert the source code into an application. Step number one. Now, who is responsible for this? This build and release team will be responsible for that. They will be taking the source code. They will be building. What they'll be building? They will be building an application out of it. Okay, how to build, what are the tools that we will be using for building, we'll see later. Okay, for now, simply they'll take the source code and they will build the application by using some kind of tools, so that we'll get application. Okay, as an example, I said Facebook application, so that Facebook application will be built here. Okay, next, these people will be releasing the application. Okay, so it's not that once they have developer written the code and the build and release team has built the application directly, they will deploy that into server. Okay, what if the application is not working as expected? Okay, so before deploying it into server, the application needs to be thoroughly tested, right? Okay, so directly before deploying into the server environment where end users are accessing, right? This server is called as production server. This server is called as production server because we people, end users, are interacting to the server to access the application, which is live server. Okay, because the application which resides into this server where end users can access the application. That's what is called production server. So before deploying the application into production server, we need to thoroughly test the application, right? So they will be releasing the application into the testing environment. Okay, the next phase would be testing. So testing team is involved over here. Okay, so what this testing team will be doing? Here also they will be having a server which is called as a testing server. Okay, so within the testing server, the people will be having some kind of tools. Okay, so that they can thoroughly test the application. Okay, this release team will be releasing the application into testing environment, and this testing team or test engineers will be logging into the server and they will be thoroughly test the application by running the test cases. Okay, if the application is working fine, then only we will be proceeding the for the further deployment of the application. Okay, so if everything is working fine, then only we will be moving to the production environment. Otherwise, the application will be again, this test engineers will be raising some bugs. Okay, if there is any bugs, again they'll send the report to the developers. Again, the developers will be correcting the code, and the correction of the code again has to be built, right? So the build team will be taking the code, they'll be building the application, and the testing team will be testing the application. Okay, always remember, this is the important fundamental to remember. Testing team will always test the application, not the source code. Okay, if testing team wants to test the application, they will be testing the application only. Okay, they'll be seeing, okay, if they enter wrong email address, and if they don't want to enter, if they okay, they enter some wrong password, if they click on login, whether login button is working fine or not. Okay, if this link is working fine or not, everything. How they'll be testing? They'll be testing the application only. What they'll be testing? They'll be testing the application only. They won't test code. Okay, so this is what the basic flow, right from the development to the deployment. Okay, uh, clear up to here, everyone,
Yes, yes, yes,
right? Okay.
yes,
Hmm.
sir.
Right, good. Okay, and now, as a DevOps engineer, first thing, what we need to do? We need to take the code from the developer, and then we will be building the source code. Now, let's try to expand this a little bit. Okay, it's not that only one developer will be writing code, right? There will be some other developers also in the team, right? So entire application will not be developed by only one developer. There might be, there will be a group of developers. Okay, more than one developer would be there. Now, this group of developers will be writing the code in their laptops. Okay, they'll be share the code. Okay, they'll be share the functionalities, and they'll write the code in their laptops. Now, it's hard for the build and release team to go to each and every developer to collect the code, right? So, build and release team needs to go to each and every developer and they need to collect the code. But some developers will be in US, some developers will be, you know, in Australia, some developers will be in India, some developers will be in Chennai, some developers will be in Mumbai, right? So, build and release team, they don't know about that information. So, okay, so each and every developer, what they'll do is they'll take a server. Okay, first the development manager, what they'll do, they'll take a server. Okay, and they'll create a folder in that server with the project name. Suppose the project name is XYZ or something, Facebook or something. Okay, Let's say Facebook, I'll say FB. Okay, and they'll ask each and every developer to upload the code to this server. Once, okay, whenever they have finished writing code, they'll be uploading the code, or they'll be asked to be to upload the code into this server or to this folder, to the folder which is there in this server, so that the build and release team, so that entire code will be available in this server, so that this build and release team will can take the code directly from this server itself, right? So this is also a server. Okay, this is also a server. This is also a server. This is also a server. Okay, what exactly is server? We'll see tomorrow. Okay, for now, just server is also nothing but a machine. Okay, uh, okay. This is called as source code repository server. This is called as source code repository server. Why it is called as source code repository? We'll see in the coming days. Okay, for now, just okay, this is a source code repository server which can hold the entire source code which is developed by the all the developers, so that the next team, builder release team, can take that code and they can easily build it. Okay, now, okay, so as a DevOps engineer, if they don't have the source code repository server, we should be enable, or we should be able to download, or we should be able to create one source code repository server for them. We should be able to create a directory, or a folder which is in the server, and we should be giving to the developers if it is the project which is getting started from the scratch. But don't worry, this source code repository server will be in general created by the development manager itself. Okay, so observe. Yeah. Hmm. So once the source code repositories are, once the developers have uploaded the code, the build team will be taking the code, they'll be building the application, and they will be deploying the application into the testing server. Okay. Now the testers will be thoroughly testing the application, and after testing the application, now again, okay, if the application is fine, okay, now imagine that, okay, this is a company called TCS. Okay, for this TCS, as an example, okay, TCS or something. For example, I'm taking TCS. Okay, um, it is a service-based company, right? So product owner would be someone. Suppose if I'm having an idea, okay, Facebook is not, their implementation, right? So I am having some idea in my mind, and I just want to implement it, but I don't know the technical stack. That I don't know the technical part of it. I don't know how to develop the application, but I'm having a bag full of money, okay, and I'm having idea, right? So what I'll do, I'll approach some service-based companies to go ahead and please develop my application, right? So that they can develop my application thoroughly. So I am the person who is called as product owner. Okay, I'll be contacting a company called TCS. Okay, and they have developed the application and they have deployed the application into server. Okay, now uh, see who has written the application. The developers are part of TCS, right? Who has built the application? The TCS team. Who has tested the application? The TCS team. Okay, who has deployed the application? The TCS team. Okay, so there might be chances that they might say that okay, the application is working fine. The testing team might say that the application is working fine. Okay, once the application has been deployed to server environment, I can see n number of bugs, or I can see the after seeing the end product, I can say that okay, these are the features which which is not according to my taste. I said another thing to you, but you have developed some other thing, right? There might be chances. Okay, the same company has developed, the same company has tested, and the same company is saying that okay, the application is absolutely working fine. But how to believe them? Okay, so what the product owner will do? He will go ahead and hire a team from one more company. Okay, for client side testing, it is called as client side testing. In technical words, it is called as UAT. There will be a team called UAT team. UAT stands for User Acceptance Test. Okay, this UAT team will be always handled by, it's called client side testing. Okay, so he'll go to Capgemini, or he'll go to Infosys. So he'll hire a team for testing. Okay, once this TCS team say that okay, the application is having, it doesn't having any bugs, or it is not having any bugs, the application is working fine, then simply I'll ask the TCS team to give the application to this UAT team, which is client side testing. Okay, so the next application will be deployed into the UAT servers. Okay, which is about UAT environment, and people from other company. Okay, my side I hired a team, right? Like from Infosys or something. So they will be logging into this servers, and they'll be thoroughly test the application. Okay, if they say the application is working fine, exactly. Okay, it is having no bugs, then only as a product owner I'll give the permission to deploy the application to production. Otherwise, I'll not allow them. Okay, for double confirmation. Okay, so once, yes, UAT also done. Okay, there will be always fight between TCS testing team and the UAT team, because these are for two different companies, right? So this UAT team definitely, they'll try to catch as many bugs as they can. Okay, the product should not have any bugs. Make sure the product should not have any bugs, so that the product owner can make some revenue out of it. That is what the main goal of any company, right? So if you go to Amazon, if the Amazon company is having some kind of bugs in their product, definitely you are not going to use it, right? Even you tell to your friends that okay, please don't use that application, it is having so many bugs. Okay, so this is how the flow. So the application, right from the developer's laptop, the flow, look at the flow, right from the developer's laptop to the source code repository server, right? And then to the build team, so that they can build the application out of the source code, and then it will be sending to testing, and then it will be sending to the client side testing. Once it is done, then we can go ahead and deploy that to the production server environment. This is what the, okay. And here also, it is not a single server, right? So if a single server, for example, have deployed Facebook application. Okay. So this server is having some kind of a capacity. It is having some 32 GB of RAM, okay, and some 16 cores of CPU, which, okay, it is having some hardware capabilities which can request or which can serve a limited burden. Okay, so which can serve the, for example, if the users are getting increased, okay, the application needs, then obviously we need to scale the servers, right? Okay, so if a single server can't able to handle all the requests, what I'll do, I'll go ahead and add one more server. It is called scaling. Okay, so that previously one server is serving my application, now multiple servers will be serving my application, so that I can handle more users, much more users. Okay, if the users are getting increased, what I'll be doing, I'll be adding one more server to the production. Like this, okay, any application you take on the production will be having a group of servers. Okay, according to the application users, we'll be having a group of servers which are serving our application. Okay, clear? So this is what the overall flow. Now, what we need to do? Okay, so see, right from once the developer will be writing the code, and they'll be pushing the code to the source code repository, right? So from there, whatever the flow is there, right, from build to test, test to UAT, and UAT to production, we need to make sure the entire flow. Okay, we need to automate the entire flow. Before DevOps, it is all manual process. But when DevOps come into the picture, we need to automate this entire flow. This entire flow is called as a CI/CD flow. What is this entire flow is called? CI/CD, which is a very, very main or important discipline, or one of the disciplines of DevOps. CI/CD. CI/CD stands for continuous integration and continuous deployment. I'll write this. Okay. What is the first discipline of DevOps? CI/CD. CI/CD stands for continuous integration and continuous deployment. Okay, we'll don't worry, we'll talk about each word, what is integration, what is deployment later, but on overall, okay, on the overall flow or on the overall idea, this entire automation process, right, from taking the code from the source code repository, building it, sending it to test environment, and then to UAT, and then to the production deployment is called as CI/CD. You need to automate the entire process. This is what the first job. And what is second job? Okay. So as an example, I said, right? So we'll be having a group of servers. If these four servers are not able to process all the requests, we need to add one more server, right? Okay. Now, as a DevOps engineer, what you are going to do? You are going to create the servers. Okay. You are going to create the servers. Okay. How we are going to create? You can go ahead and create by using manual process, or or we will be doing some kind of automation. Okay, will not be creating manually. If you could go ahead and create manually, it will take so much of time. Okay, meanwhile, okay, for example, if I'm running on running with two servers, if these two servers can able to process some 100 requests per second, as an example, if I'm getting 200 requests, then automatically the servers will give response very lately, right? So if I start creating a server manually, it will take another 20 minutes or 25 minutes of time, right? So till the time the existing servers may get crashed. So I need to automate this entire process. I need to go ahead and add the servers on the fly. Okay, we need to even create the automation of this creating the servers. Okay, this is called infrastructure as code. What is this called? Infrastructure as code. We'll write a script file. Okay, what we'll do? We'll write a script file to create the servers. Okay, and once if you write the script, once you run the script, the servers will get created. Okay, within the script, we'll mention the count. Okay, I want two servers. If you run the script, two servers will get created for you on the fly. Okay, if you want 10 servers, just we'll update the count and then we'll just simply run the script. Okay, so we are not going to create the servers manually, but how we are going to create the servers? By writing some kind of automation scripts. Okay, what this is called? This is called as infrastructure as code. Okay, let me write that point. The second discipline of DevOps is called as infrastructure as a code. Okay, once the servers are ready, okay, once you deploy the server, once you create the servers, next, it's not that only, sir, example, you want a Linux server, okay, you'll go ahead and create a Linux server, but on top of that, your application requires some Java. Then your server should have a Java, right? Your server should have Java installed in each and every server. So if you create a new server, within that server, Java should be there. And within the server, some user account would be there. Within the server, some kind of web server should be there. Within the server, some kind of database server should be there. Okay. It requires some configurations. It's not that blindly we can go ahead and create a server and we can attach the server to the, no, this production server group. No, it should have some configurations. Okay, it should have web servers. It should start some services. It should open. It should have some open ports. Okay, it should have some network configurations. Right, all these are cluster of servers. It should have some network configurations. Right. So who will be doing these configurations? Again, we need to do. Okay, whenever you create a new server, you need to do the configuration management part. Okay, how we are going to do the configurations? For that also, we'll write a scripts. We'll write some scripts. Okay, if you run the script file after creating the servers, if you just run the script file, okay, so this script will get executed on all the newly created servers, and these servers will be configured with all the required servers or all the with required softwares or with all the required configurations. Okay, that is what another discipline. It's called as configuration management. Okay, so these three are the major disciplines of DevOps. Okay, apart from these three, you won't be working on any discipline. Okay, if you join any organization, your work would be either one of them, or your work would be either two of them, or your work would be either three of them, depend upon the company's size and your team size. Okay, now once observe, just go with the points. First, once we create the servers by using some automation script, and then okay, we'll run the configuration management script so that these servers are configured by the required softwares. Okay, servers have been configured with the required softwares. Okay, and it should have the application, right? Then only we can use them, right? We should be deploying or should be able to deploy the application into the newly created servers, which called application deployment, which will be happening through this CI/CD process, right? We'll be taking the source code, we will building it, testing it, and from UAT, we'll go ahead and deploy that application, or we'll go ahead and take the application into the newly created or newly configured servers. This is what majorly we need to do. Okay. Now, sir, clear up to here?
Yes.
Yes, clear, right? Now, okay. What is the purpose of cloud, or where exactly cloud usage over here? Okay, always we'll see a terminology, a term with along with DevOps. We'll see Azure DevOps, or we'll see AWS DevOps, or we'll see GCP DevOps, right? So always there would be a cloud attached to DevOps. Why? Why there is a cloud attached to DevOps? Okay. Now, if you want to create a server, here we'll talk about so many servers, right? Okay. If you want to create a server, if it is a manual server, it's a physical server in your organization, then you know the process. If you want to deploy a server, how many requests and how many approvals should be there? We need to raise a request. Okay, this much RAM capacity, this much CPU, this much hard disk is required, and it will go to some other person. He should approve, and then it should go to the vendor. He should approve, and then from there, okay, so many lots of approvals should required, right? So for example, if you're running with the two servers with an application, and the traffic to the servers or the users who are using the applications are getting enormously increased, and if you want to add a new server on the fly, if it is a physical server, it needs to go through lots of approvals. It will be taking days of time. But if you wait for days of time, these servers will get crashed because of the burden on them, right? So if we want to create the servers on the fly, then how can we create the servers on the fly? We will be taking any cloud provider help. Any cloud. You go with AWS cloud, or you go with Azure cloud, or you go with GCP cloud. What you'll be doing? From this cloud, first thing, we'll be taking the servers. Okay. Now in this course, which cloud that we are using? We will be taking AWS cloud. We'll be using AWS cloud to create the servers on the fly. Okay, on cloud, if you want to create, it won't take much. It won't take more than 5 minutes or 6 minutes. Okay, which is a decent amount of time. Okay, if you are using AWS cloud for your infrastructure, it will be called as AWS DevOps. If you are using Azure cloud, it will be called as Azure DevOps. If you are using GCP cloud, it's called as GCP DevOps. That is what the difference. Okay, but whatever the cloud that you use, the concept will not change. This is the concept. Okay, CI/CD, infrastructure as code, configuration management. Okay, for the infrastructure as code here. Okay, now we'll talk about the tools which we are using. Okay, for this source code repository server, we'll be using a tool called Git. Okay, for this build and release management, we'll be using a tool called Maven. Okay, test engineers will be doing. You don't need to worry. They'll be doing some kind of automation test by using Selenium, and you are not responsible to write the test codes. Okay, don't worry. The testing team will be taking care. Okay, so here for testing, okay, for the namesake I'm writing for the testing side, they'll be using some kind of automation testing, which is called as a Selenium. There's a product called Selenium. Okay, and UAT also for testing. They'll be using Selenium as well. Okay. So at the production side, the server side, okay, we'll be learning web servers and Apache Tomcat. Okay, I'll write here. Okay, what we'll be learning? We'll be learning web servers, which is nothing but HTTPD or Nginx, and we'll be learning Apache Tomcat. Okay. Uh, Now, I'll just write this point over here. Okay, for source code repository, just quick review of this one. Quick recap, you can say. For source code repository, we'll be using Git. For building the applications, we'll be using Maven and we'll be using NPM as well. For example, on high level, just I also want to put a single tool for that. Okay. For testing Selenium, but we will not be running the test case or will not be using the test cases or we will not be writing the test cases. Don't worry. And for servers, we'll be using AWS Cloud. And in order to run the applications, we'll be using web servers and Apache Tomcat. So these are the tools that we'll be using on high level. Okay. Now, okay, all these are part of CI/CD, right? All these are part of CI/CD part. First, I'll just quickly summarize this one. Infrastructure as code. For this, what kind of tools that we'll be using? Infrastructure as code. It means in order to create the servers. Okay, we'll be using AWS Cloud and we'll be using Linux. Okay, majority of the cases we'll be using Linux servers only. For the entire course, we'll be using Linux servers. Okay, it would be good if I write this Linux over here. Okay, I'll just write Linux. Next, for the configuration management. Okay, let me write the point here itself. For infrastructure as we have to create the servers, we'll be using AWS Cloud. And for the configuration management, which means once you create the servers, okay, it needs to be configured with different software, right? So for that, we will be using Ansible. Okay, in order to write the automation scripts. But before that, we need to know Linux because those are Linux machines. On Linux machines, you should know how to install a package, how to start a service, how to open a port, okay, and so many things, how to create directories and how to copy files. So many things are there which would be there in Linux. So first we'll be doing manually on Linux everything, and then we will be writing the automation scripts using Ansible. I said right. If you want to do configuration management, you won't be doing it manually. How will be doing? You will be writing a script file and you will be running that script so that the script will execute it, and whatever you're running the script, right? Whatever you have written in the script, this will get executed on the servers and all the servers will be installed with the required softwares. If you want to do it manually, it will take days of time. But with automation script, we can finish it off in 10 to 15 minutes. Okay, so this is the manual stuff using Linux, and then we will be learning the automation script in Ansible. Okay, whenever you heard term called automation, okay, think about scripts. Yes, we need to write scripts. DevOps also will be having code, but it's not kind of a Java code or .NET or something. It is very, very with very, very simple and easy scripts. We'll be writing our automation tasks. Okay. Next, infrastructure as code. As I said, right, by using AWS Cloud, we can go ahead and create the servers. But I want to create the servers on the fly. Okay. Here, like this, if I want to create servers, what I need to do, I need to write a script and I need to put some count. If I run the script, some servers needs to get created automatically, right? For that automation part, in AWS Cloud, we'll be learning manual creation, and with the automation, we'll be learning Terraform. Okay, this is what automation. And for the CI/CD, continuous integration and continuous deployment. First, we'll see the entire flow manually. Okay, how to create this source code repository server, how to upload the code to the source code repository server. Okay, from then how to take the code, how to build it manually, and then how to deploy it to the testing servers, how to deploy it to the production servers. Everything we'll see manually. Okay, for that we'll be using Git, Maven. Okay, we'll be doing a Tomcat and a web server. I'm just keeping the thing simple. I'll say Git, Maven, Tomcat. Okay, these are tools that we are going to use on a manual thing. Next, as I said, right, we need to automate this entire process, which is called as CI/CD process, right? For this CI/CD, we'll be learning a tool for the automation, which is called as Jenkins. Yes. Okay. I said Jenkins, right? So within Jenkins, we'll be having, or we need to write some kind of scripts, which is called as pipeline scripts, which we'll be talking about later. Okay. So these are the manual things, and it is the automation part. And AWS Cloud is the manual thing, and Terraform is the automation part. And Linux is a manual thing, and Ansible is the automation part. So these three are the major disciplines major disciplines for any DevOps engineer. You can see these three are the main major responsibilities of any DevOps engineer. Okay, if you join in any MNC, you might be working with any one of them. If you join in any mid-scale organization, you'll be working either two of them. If you join in any kind of startup, you need to go ahead and work on these three. Okay, it's not that entire thing you'll be working. You might be working on any one of these disciplines. It depends upon your, company and your team size. Okay. Apart from this, okay, we'll be having something called as containers. Okay. For now, just imagine these containers also nothing but servers, okay, which are lightweight servers. Okay, even those are containers or servers, the process is same. The entire process is same. Okay, these three processes will not get changed. Okay, containers are nothing but lightweight servers. Okay, for these containers, we'll be using Docker and Kubernetes. Okay, these also two other tools that which we are going to learn as part of this course syllabus. Okay, so you should be very very good with these two, because nowadays everybody wants these two tools. Okay, but you should have the foundation of all this. On top of it, you should have the knowledge on Docker and Kubernetes. Not knowledge, you should have working experience in Docker and Kubernetes. Because now majority of the projects are on containers. Those are not on servers. You might be having some of the applications on servers, and you might be having some of the applications on containers. Nowadays, people are majorly using container based applications. Containers are nothing but lightweight servers. Why they are going for containers means, even though if you write any automation script to create a server, okay, in order to create a server, it will take minimum 10 to 15 minutes of time, right? But if you go for container based, what is container and how it looks like, how to work with containers, we'll see. But on a high level, these containers are nothing but lightweight servers. Right? If I want to create a container within second, within fraction of second, I can go ahead and create a container. Right? If my container is ready within a second, then I can go ahead and run the configuration management on top of it, and I can deploy the application right within couple of seconds or couple of minutes. So the application deployment time will get enormously decreased. Otherwise, if these, for example, if two servers are running the application, okay, on the burden on top of these two servers are getting high. If I start creating the server, even though with automation script, it will take another 7 to 10 minutes of time. Up to 10 minutes, these two servers need to handle the all the requests, right? Meanwhile, these servers may get crashed. But with if you go for the containers, within seconds or within minutes, you can go ahead and create the container, we can configure the container, and we can deploy that application into the containers, right? So that is what everybody wants. So that is what the latest technology, which is called as containers. For that, we'll be learning Docker and Kubernetes on top of it. Okay. uh, Clear?
Yes.
Yes, any doubts? Any doubts so far?
Now, which things we
Clear,
will
right? Yeah,
edit?
yeah. Good, good. Yeah. Hmm. These things, you're saying something.
Which things
Hmm.
from AWS we will cover?
Which things
We,
are, we'll complete we'll learn all these things.
uh, which we will require for only DevOps, no?
Yes. Yes, we'll be learning all these things because all this part of DevOps course.
No, no. I am
Hmm.
asking uh, which things we will cover from AWS, like EC2 and
Okay, okay. So I said AWS cloud. So you got confused. Which thing that you will be learning on AWS cloud? Okay. So whatever the things that are required,
also.
okay, in order to complete this entire CI/CD process. Okay.
Okay.
It's not about 20 services or 25 services or 30 services. Okay. So it's all about what are the services that are required in order to achieve this. We'll be doing entire thing practically, right? So we'll be taking couple of projects and we'll be doing CI/CD process, we'll be creating servers. All these are depends on practical things. So while doing practical things, we'll be learning each and every service, like what are the services that are required. Okay.
Yes,
For
yes.
example, you asked, I will be using EC2, we'll be using VPC, we'll be using public subnets, private subnets, and we'll be using S3, we'll be using IAM service.
Mm,
Okay, what are things that are required? AWS CLI. Okay, you can say all the base things, EBS volumes, EBS snapshots. Okay, right?
yes.
Yeah, I will be using load balancers, application load balancers, network load balancer, and when to use what. It's not that okay, simply we are learning. Okay, we'll be learning on a, okay, where with the requirement based. Okay,
Okay.
start a project. We'll take the requirement. According to the requirement, we'll slowly build up the infrastructure. Okay, clear?
Yes, yes.
Right. Okay. So that is how we actually we need to learn. Then only you can understand. Then only you can remember. Okay. If you start learning service by service, you can't remember anything, and that is not the right way.
Mm,
Yes, right. So we'll
yes,
be taking the requirement, and then from out of the requirement, we'll see what are the things that are required, and those things will be slowly creating, and we'll be linking each and everything. Okay. Link is important. Integration is important. On AWS cloud, we'll be integrating all the services, and then those service once we create the infrastructure, right, we will be integrating that with other things as well. Okay, right, from in order to form the CI/CD.
uh, I want to ask one more doubt, sir.
Yeah, yeah, go ahead, go ahead.
Uh, what is the role of DevOps engineer for the operation side?
Uh, okay, so these two actually comes under the operation side, not
Which
these
which?
two, these three: infrastructure as code, and configuration management,
Okay,
and creating the containers. You can say these three.
okay, okay.
Okay, nowadays the CI/CD, once we create the CI/CD pipeline, right, the developers can be able to run the CI/CD scripts. You don't need to be much involved in that. Whenever if they faced any errors or anything, then only we can pitch in and we can go ahead and we can resolve them. Okay, the main thing on the operations side, these are the operations things mainly.
Okay.
Okay, so entire thing we need to take it. These are these three are these four. Okay, these three actually are the main responsibilities for any DevOps engineer. Okay, we should know all these things. Okay, it's not that you should have the knowledge of Java, should have the knowledge on .NET or something. So you should know the flow. Once the developer has write the code and what are the other things from there. Okay, so what are the different stages that it involves? No,
Mm,
the entire flow you need to understand. Okay, only we will be leaving this part. We are not responsible for writing the code. The
okay.
writing code will be taken care by the developers, and from there, whatever the things that are there, right, you should be have a good hands-on experience in all those things. We might not know, right? So on which thing that you are going to be placed and you are going to work. Okay, you might be working on only containers, which we don't know, right? So we need to make sure we will be having knowledge on all these things, and you should have practical exposure. Okay, not a theoretical thing, and should have practical exposure as well, from the concept based, from right from the scratch, from the concepts to the advanced level. Okay, so we'll be having Ansible. Why Ansible? Why not some other tools? Puppet and Chef are there. What is the difference between all those things? And so many technical things are there, which will be discussed. Okay, It's not that directly I'll start Jenkins and I'll put heading Jenkins and I'll start installing Jenkins. Okay. We'll try to understand what is the use of that, why we need Jenkins, okay, and what are the other tools are there and why we have selected Jenkins. With Jenkins, what is the advantage? Without Jenkins, okay, how things looks like. We'll try to understand all those things and then we'll start actual concept and then practically we'll just go with that. Okay. So go to aws.amazon.com. Okay. Awesome. aws.amazon.com. Okay. Go ahead and create a new AWS account. They'll charge 2 rupees. Okay. Just a minute. Arey, అది అయిపోయింది అనుకో. మీ క్లాస్లో ఉంది. వాడు అయిపోయింది అనుకో. Okay. So yeah, you can go ahead and create an AWS account. It requires a debit card. Who will charge? It will charge. They'll charge minimum 2 rupees, and within 24 hours, again your 2 rupees will be credited into your account. You don't need to worry. For authentication purpose, they'll charge that. Okay. So once you create your account, right, you can use it free. You can use it for free for almost an year. Okay. For 365 days, you can use your AWS account for free. Okay. Almost majority of the services you can use them for free. Okay. For this course, this is the main thing because we talked talked a lot about the servers, right? So we are going to create all these servers on the entire infrastructure on this AWS cloud. Okay. So before within a couple of days, just go ahead and create it because once we start the practicals, right? So if you are unable to create or if you did not create it, okay, you'll get lagged. Okay, so daily what are things that we are doing in the class? Just you need to make some time and just you need to practice all those things, and you need to finish that within that day itself. Don't postpone the practice. Okay, just if you have time, just go ahead and create your account. Yeah, so that's it for today. And in the next session, we'll see what exactly a server is. Okay, we'll talk much more about the servers. Okay, the practical approach. We'll see that. If you have any other doubts, you can ask me any technical doubts or anything.
No,
Nobody talking something? Dharmarajan, do you have any doubts?
No, sir.
Clear, right?
Sir.
yes,
Yeah,
sir.
clear, sir. Because I
Okay,
am in other meetings. So sorry for trouble.
fine, fine, fine,
Because
fine.
I am.
Yeah, fine. Yeah, Anup, go ahead. You're
हाँ,
asking something.
हेलो
Yeah, yes, Anup, go ahead.
नहीं नहीं कुछ
कुछ नहीं ठीक है चलो right, that's it from today. Okay, the next class hopefully we'll put on Monday or something, by Monday I guess.
नहीं
uh, by 7:30 is it okay? 7:30 in the morning.
yes sir
Okay,
I'm
so yeah, so just confirm the timings with the admin. Okay, I think you guys have the number, right?
हाँ yes
Yeah, yeah. So they'll be informing you. Okay,
yes
so hopefully most probably it will be on 7:30. Okay, 7:30 to 8:30, and after that I need to go to office even, right? Yeah. So those are the possible timings, and the class timings will from Monday to Friday, and Saturday will take whenever I put class, right, we'll take for a couple of hours, like 4 hours or 5 hours, because we need to cover huge syllabus. The syllabus is very huge. You can see the list of tools over here, right? So all these things, it's practical approach we need to cover. Okay. If I take Saturday or Sunday, it will be like 4 to 5 hours of session. Okay. Some days it might take longer, up to 6 hours as well.
yes
We'll plan that. Okay. Right. Okay. Thank you. Thank you everyone for attending the class. Have a good day. Right. Thank you, sir. Bye.